Well, hello, my friends. Welcome back to another exciting lecture in the topic of probabilities. In this particular video, we will examine Lesson 8 of Module 1, the probability laws. Now, a probability law specifies the likelihood of any event or set of events. A probability law assigns to any event A probability of A. I want you to notice this notation in the probability of A. The probability law says that if A occurs, this is the probability that A will occur. Some of the probability axioms that we will be using, first of all, that of non-negativity. Probability is always a positive number. Actually, the probability of A is not only a positive number, but it should rest between 0 and 1. So between 0 and 1 is the level of probability. 0 being a 0% possibility, 1 being 100% likelihood that the event will occur. We also have an additivity event for probability. The probability of A union B is equal to the probability of A union with the probability of B if the two sets are completely disjoint. Now, normalization, the probability of the universe happening is 1 or 100%. And then the probability that nothing happens in the empty set is 0. All this really says is that probability ranges from 0 to 100%. And that's what we've said about it here. The probability runs from 0 to 1 or 0% to 100%. Now, some of the probability rules. In this rule, the probability of A union B union C is equal to the probability of A union with the probability of B union with the probability of C if A, B, and C are disjoint. If the omega, or if the sample set consists of n possible outcomes, which are equally likely, then the probability of A is given by the following formula. The number of elements in A divided by the number of possible outcomes. The number of elements in A divided by the number of outcomes is the formula. For instance, in our past study, what is the probability that we flip a coin 3 times and we get a head, heads, and then a tails? We notice that there's only one outcome that matches this requirement. There were 8 possible events. One event that matched it, 8 possible events, so 1 divided by 8 is 0.1250 or 12.5%. So in this particular experiment, the possibility of getting an event of heads, heads, and then a tail is 12.5%. The probability of A is always equal to the number of elements in A divided by n. Again, the probability of getting a heads, heads, tails is 12.5%. Now, some of the properties of probabilities are interest to us. Here's one. If A is a subset of B, then the probability of A is less than or equal to the probability of B. If A is a proper subset, which means A has less elements than the B, then the probability of A would be less than the probability of B. But since A being a subset of B, a set can be a subset of itself, then we have to say that it's possible that it might be equal to B. So if A is a subset of B, then the probability of A is less than or equal to the probability of B. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of their intersection. The probability of A union B is always less or equal to the probability of A plus the probability of B. The probability of A union B cannot be more than the probability of A plus the probability of B. Many times it will be less than that amount because the probability of A union B may be an actual value that comes into play. Now here's a different type of group. This is the probability of A union B union C, probability of 3 sets. A little bit more complicated formula. Probability of A plus the probability of A complement intersect B, plus then the probability of A complement intersect B complement intersect C. This is a much more extensive rule to utilize than just the probability of A union B. It is interesting to note here that if A and B are disjoint, then they have no intersection. So the probability of the empty set is 0, so the probability of A union B just simply becomes the probability of A plus the probability of B if they are disjoint sets. Again, I want to thank you very much for your support. This video fairly well wraps up our first run in this, and then we will move to a module 2. As always, may the odds be ever in your favor. You have a great day.